So we have a question here that tells 10 identical cells are connected in series are needed to heat a wire of length 1 meter and radius r by 10 degrees centigrade. So there are 10 cells it seems, and those are needed to heat the wire of what length? Length is given as 1 meter and radius is given as r. Length is 1 meter. We will note down the data. R radius by 10 degrees centigrade. How many cells will be required to heat the wire of length 2 meter? How many cells are required? Of same radius by the same temperature in the same time. So we know that amount of heat which is produced in the resistor is given by what? Power into time, and that heat will cause a rise in temperature which is given by mc delta t as seen from the previous examples. Amount of heat produced is mc delta t, correct? Or power into time, and that will be used to rise the temperature, and the amount of heat which we have to supply to rise the temperature of the body by certain amount is mc delta t. Now power, as we have seen, power can be written as I square R into T, that is equal to MC into delta T. M is the mass of the wire, be very careful, or the resistor's mass here. Now, what is the current? Since it is a one loop question, it is a one loop question. So only one current will flow in the circuit. The current is given by the net EMF divided by the net resistance. So what is the EMF, people? Because 10 cells are there and all are in series, we can take it as 10E, and resistance of the wire, I will take it as say R. And let me write here carefully. Let me write here what is R. R is nothing but rho into L by A. And what is A here? Because he's specifying length, radius. So let me expand this area by writing pi R square. And how much is the length, people? To heat the wire of length 1 meter. So length is 1 meter. So initial resistance, I can take it as R. Getting it? And then I'll put this value of current. So this is how much I square will become 10E by R the whole square into R into time is equal to mass of the wire into specific heat into delta T by 10 degrees centigrade. So the rise in temperature is 10. So call this as equation number 1. This is the first part of the data. Now the question is how many cells are required to heat a wire of length 2 meters. See, now what will be the resistance now? Resistance will be length will become 2 meter divided by pi into of the same radius. You can see that only length is getting doubled. Only length is getting doubled, but the radius is same. So pi into r square. So this is nothing but rho into 1 by pi r square is r. So in the second case, the resistance is going to be, since you have multiplied this part by 2, so the resistance is going to be 2r. In the first case, if you take it as R, R1 if you take it as R, in the next case, it is going to be how much? 2R. Not only this, even the mass is going to double because you had one area, isn't it? You had only one wire. You had one wire of length L. Now you're doubling the length. You're doubling the length. Basically, you're placing one more wire to it. One more wire next to it. So what will happen? Even the mass is going to be doubled. So mass, the new mass will become how much? Mass will become 2 times of M. So in the second case, let us say this is case 1. Let n be the number of cells. Let n be the number of cells required in the second case, in case 2. Now, what is the amount of heat produced? Again, we can use the same formula. Heat is nothing but I square R into T is equal to, then this heat will cause a rise in temperature, which is MC delta T. Now, what is the current? The current is nothing but the net EMF by the net resistance, because we have assumed n cells. Before there were 10 cells, so it was 10E by R. Since it is n cells, it will be, current will be the total EMF NE divided by the total resistance. What will be the total resistance? Here the resistance was just R. Here the resistance became how much for the wire? 2R. So this is the current multiplied by the resistance. Resistance is now 2R into same time by the same temperature in the same time. So time is same. Mass will become how much? Mass is going to be 2m. Specific heat is constant for a given material. Delta T is again how much? 10. Call this as equation number 2. And he's asking us the value of n. So we can just divide the two equations and we can then solve them. So if you divide the two equations, 2 divided by 1, 2 divided by 1. So what will you get? If you divide the left hand side, you can see that this will become n square E square by 2R the whole square will become 4R square into 2R into T divided by this part. So this is going to be 10 square into E square divided by R square into R into T, that is equal to 2m into C into 10 divided by m into C into 10. We are just dividing equation 2 by 1. Now what will this become? We can see that 1R, this 1R will cancel out. Similarly 1R will cancel out. and this R and this R is going to cancel out. Time will cancel. E square will cancel. MC10, almost all the values, all the variables will get cancelled. Now I'm having two ones are 2 and 2 also will cancel here. 2 and 2 also will cancel. Next, I'm left out with the n square divided by 10 square is 100. 100 into 4 is 400. So only 1 is left out here. So this implies n square is equal to 400, or this implies n is equal to root 400, which we get it as 20. Therefore, 20 cells are required to heat up a wire of length 2 meter and the same radius by the same temperature in the same time. So 20 will be the answer. First option. Next question. Next question, we have two bulbs B1 and B2 rated 50 watt and 100 volt. We have bulb 1. What is the specifications of the bulb given, people? 50 watt and 100 volt. And bulb 2 is also there, which is given as 100 watt and then 100 volt. So what are these called? These are all called as specifications. These are called as what? Specifications. Almost every electronic gadget specifications will be mentioned, and those specifications will be given in terms of power and voltage, which are also called as power and voltage ratings. Every electronic gadget, correct, will be mentioned with the power and the voltage ratings, which we call it as the specifications. It basically means the bulb can consume maximum power of 50 watt, and then the maximum voltage that can be dropped across the bulb is 100 volt. If it is more than 100 volt, then the bulb is going to fuse out, isn't it? If there is no fuse, then the bulb will burn out. So this you cannot, the voltage drop across this bulb cannot be more than 100 volt. If it is more than 100 volt, it will fuse out. Similarly, here also across this bulb, if the voltage is more than 100 volt, what is going to happen? It is going to fuse out. Now from the ratings, what we always do is you can write that from the ratings, this is the point to be understood. So this is, you can write it under a note. From the ratings, we always calculate the resistance of the bulb. We can also calculate the safe current of the bulb that the bulb will handle. But here only we will calculate the resistance. We always calculate the resistance of the bulb. What can we calculate, students? Resistance of the bulb. So how do you calculate resistance of the bulb? So here power is given, isn't it? Power is given and voltage is given. So from the specifications, not from the applied voltage, don't see that it is connected to 220 volt source. Which of the following option is correct? He's asking which bulb will work and which bulb will blow out, he's asking. So don't see the applied voltage. First you see the specifications, and from the specifications, you calculate the resistance. So when P and V is given, how do we calculate resistance? We know P equal to V square divided by R. So this implies a resistance is nothing but V square divided by P. So from this, what is the resistance of bulb 1? Resistance is V square, which is 100 into 100 divided by P. P is nothing but 50. So therefore, this will become 100 into 2 will become 200 ohms. And then what is the resistance of the second bulb? Similarly, V square, which is a 100 multiplied by 100 divided by 100. So 100 will cancel. You're going to get 100 ohms. Now it will be a simple circuit based question that you have to solve. So you need to just calculate the resistance of the bulb and replace the bulb now by its internal by its resistance, and then solve the circuit in the normal way. So I'm going to write here. So here I have replaced the bulb 1 with a resistance of 200 ohms, and the second bulb I have replaced by resistance of how much? I have replaced it by resistance of 100 ohms. And then this is connected to what voltage? Both are connected in series to a voltage of 220 volt. Which of the following will be correct? Now a circuit is given for me. What I do with the circuit, I find the net resistance and I find the current supplied by the cell. So what is the current supplied by the cell? The current supplied by the cell will be equal to the total voltage by the total resistance. Total voltage is 220 volt and the total resistance is 200 plus 100, which is 300 ohms. So 1010 will cancel. 2 11s and then 2 15s. So 11 by 15 ampere will be the current that will be supplied by the cell. Now, after finding out this current, now you can calculate how much voltage will be dropped across the first bulb and how much voltage will be dropped across the second bulb. Now compare this voltage with the rating, and then you can come to a conclusion that which bulb will work and which bulb will fuse out. So what is the voltage V1? So therefore I'll just solve here. V1 is equal to I into R1. So I is nothing but 11 by 15 into 200. So this is going to be 5 3s are 15, 5 3s are 15, 5 4s are 20, and then 0. So this is going to be approximate calculations we can do. Three ones are three, and then remainder one, three threes are none. I have just done some approximations, some safe approximations I'm doing. Now 11 into 13. So if you multiply this 11 into 13, three ones are three, three ones are three, one ones are one ones are one, three, then 3 plus 1, 4. This is 143. 143 volt. 143 volt is the voltage drop across the bulb one. Obviously, it is going to fuse out because the maximum voltage that can be dropped across the bulb is 100. But after connecting it to a 220 volt source, I find that the voltage that is getting dropped is 143 volt. Therefore, definitely it is going to fuse out. So this bulb will blow out or fuse out or blow out. What about the second what is the voltage across the second resistor? Obviously, here if the voltage is 143, obviously this is going to be how much? It is going to be 220 minus the voltage drop across the first resistor. What is the voltage drop across the first resistor of the first bulb? It is a 143. So 220 minus 143. 220 minus 143. So this will be somewhere around 50, 60, 70, around 77 volt. Somewhere around 77 volt. This will be the voltage across the second bulb, but that bulb has a maximum capacity of how much? 100 volt, isn't it? But here the voltage gets dropped is how much? 77. So this doesn't blow out. Only the first bulb is going to blow out, doesn't blow out. So option will be both bulbs will blow out. No. Bulb B1 will blow out. Yes. Second option is right. Bulb B2 will blow out. No. Both bulb will glow with maximum intensity. No. Only the second option is right. Next question we have here. In the circuit shown below, key is pressed at t equal to 0. So you're closing the switch or key at t equal to 0. Choose a correct statement. At time t equal to 0, the current flown through the battery is 4 milliampere. See, capacitor is like what? Capacitor is something like a mobile phone. It is something like what, students? It is something like a mobile phone. So what does a capacitor do? Basically, it will store charge. Mobile phone is also going to store charge only, isn't it? Mobile phone is also going to store charge. It is something equivalent to this, you can understand. Let us say your mobile phone is highly uncharged. As soon as you connect your mobile phone to the battery, then what will happen? Since the capacitor is highly uncharged, a maximum current will flow from the battery in order to charge the capacitor. A maximum current will flow because it is highly uncharged. It will take maximum charge. So maximum current flow will flow from the battery in order to charge the capacitor. And therefore, as soon as you close the switch, as soon as the switch is closed, as soon as the switch is closed, capacitor can be replaced by what? It can be replaced by a closed switch because maximum current is flowing. And when will maximum current flow? Only when the switch is closed. So it can be replaced by a closed switch. This is the first point that you have to understand. After a long time when the switch is closed, after a long time when the switch is closed, what is going to happen? After a long time, the capacitor will be fully charged. Let us say after 2 hours, it became 100%. It's not that if you keep for another half an hour or another 1 hour, it will become 200 or 300% charge, isn't it? No. So when the charging is completed, isn't it? Further charge cannot be deposited on the capacitor. So after a long time when the switch is closed, the capacitor is fully charged. Capacitor is what? Capacitor is fully charged. It cannot accept further more charge. It cannot accept further more charge. That means what should happen to the capacitor? The capacitor will act as an open switch, means no current will flow and the extra deposition of charge will stop. On the flow of current is nothing but what? The flow of current is basically the rate of flow of charges. Flow of charges will give rise to current, isn't it? So the flow of current should stop. Because the capacitor is fully charged, it cannot accept further more charge. Therefore, the flow of current should stop, and the current will stop only if it is an open switch. Therefore, current will be equal to 0. So these 2 points you have to remember. This note you have to remember, very, very important. As soon as the switch is closed, capacitor will act as a closed switch because it is highly uncharged. It will take maximum charge, and after a long time when the switch is closed, it is going to act as open switch because it is fully charged. And this state we call it as steady state. This state, what we call, students? This state we call it as steady state. Now, keeping these 2 points in mind, let us try to solve this question. So here the question tells that, so here it is 1000 ohm. Let me redraw the circuit, 1000 ohm. And this is a 6 microfarad capacitor. This is a 500 ohms. And then this is a battery, 4 volt. And here also we have a resistor, which is a 500 ohms. Now the question first point, At time t equal to 0, at time t equal to 0 means as soon as the switch is closed, what is the current flowing through the battery? So as soon as the switch is closed, what is going to happen, people? The capacitor will be replaced by a closed switch. What will be the capacitor? The capacitor will be replaced by a closed switch. So you can see that a resistor is in parallel with a wire. We know a concept, isn't it? What is that concept that we know? If you have a wire connected in parallel with a resistor, current will always try to flow in a path where there is least resistance. Since the resistance of the wire is zero, correct? Resistance of a wire is zero. Entire current will be diverted through this wire and no current will be flowing through this resistor. So this resistor is redundant. It can be removed from the circuit point of view. This only we call it a short circuit condition, where the current is flowing through the short, where the current is flowing through the wire, because current will try to flow in a path where there is least resistance. Resistance of the wire is zero. So entire current will flow through the wire. No current will flow through the resistor. So it can be removed. Same situation has arisen here. The resistor is connected in parallel with the wire. So if some current goes from the positive terminal of the battery, the entire current will get diverted through this wire. No current will be flowing through 1000 ohm. So this can be removed. This is at what condition? At t equal to 0. At t equal to 0, this is the condition. Are you getting it? Now here, so what is the current, people? How are 500 ohm, 500 ohm connected? So it is very simple. It is just a one loop question now. This is 500, this is 500, and this is a 4-volt cell. So therefore, what is the current? Therefore, both are in series. It's a one loop, one current will flow. Therefore, the current flowing is nothing but the total voltage divided by the total resistance. Total voltage is 4 and total resistance is 500 plus 500, which is a 1000. Therefore, this is going to be 2 2s are 4, 2 5s are 10, and 0. 2 by 4, 2 by 5 is nothing but 0.4. 0.4 into 2 zeros is 10 power 2 will come up. It becomes 10 power minus 2. And if I shift one decimal to the right, and I will get it as 4 into 10 power minus 3 ampere, which is 4 milliampere. This is the first option. As soon as you close the switch, what is going to happen? The capacitor, as soon as you close the switch, the capacitor is going to act as a short circuit or a closed switch because it is highly uncharged. The maximum current should flow. So the first option is right. At t equal to infinity, we will do this also. We will do this. At t equal to infinity. At t equal to infinity means after a long time, infinite time, long time, what will happen to the capacitor? The capacitor will act as an open switch. It will act as an open switch. Therefore, now you can replace the resistor by 1000 ohms. And this is an open switch. And in open switch, no current flows. So this branch is redundant. So this is 500 ohms. And this is also 500 ohms. And this is a 4-volt cell. How are these connected? It's again a one loop question. So all are in series. Now current in this case will be the net voltage, which is 4 by the net resistance, which is 1000 plus 500 will be 2000 ohms. So 2 ones are 2 twos are, and this will be 2 into 10 power minus 3, which is a 2 milliampere. 2 milliampere. This is a current when the after a long time when the switch is closed or when the capacitor is fully charged. This is 2 milliampere. So second option is obviously wrong. Let us do the third part. At t equal to infinity, what is the charge on the capacitor? He's asking us what is the charge on this capacitor. So charge on this capacitor, what is the formula, people? C multiplied by V. V is nothing but the voltage across this capacitor. And since you can see the 1000 ohm and this capacitor are connected in parallel, the voltage is going to be same, isn't it? The voltage across 1000 ohm and capacitor, it will be same because they are connected in parallel. See, if you have to find the charge across the capacitor, first you have to worry about the branch that is connected in parallel with the capacitor. Which is the branch that is connected in parallel with the capacitor? 1000 ohm. So what is this voltage? Can you tell me? How much is the current flowing? Current flowing is 2 milliampere. So what will be the voltage? I into R. I is 2 milli, which is 2 into 10 power minus 3, and resistance is 1000, which is 10 power 3. Therefore, this voltage is going to be 2 volt. You got to know the voltage. You got to know the voltage. Voltage is how much here? Voltage is 2 volt across this 1000 ohm. Same voltage will get dropped across 6 micro also. Therefore, what is the charge? Therefore, charge is equal to C into V. C is 6 micro into voltage is nothing but 12. Voltage is 2. So 6 twos are how much? 12 microcoulomb. This will be the charge on the capacitor. This will be the charge. So 1.2 microcoulomb is wrong. It is going to be 12 microcoulomb. So we have done the entire analysis. We have a question here. In the figure shown, the power generated in Y is maximum if Y equal to 8 ohm. The value of the resistance R marked as R will be how much? We have from maximum power transfer theorem. maximum power transfer theorem, which states that if maximum power is to be delivered across the load from maximum power transfer theorem, it states that if maximum power has to be delivered across the load, let us say this is the load, let us say the resistance of this load is R. Then if it is connected across the cell, say E, and internal resistance R, this resistance R is not only the internal resistance of the cell, it is the resistance of this extra wires and all these things. So if maximum power has to be delivered across the load, then the condition is the resistance of the load must be equal to the internal resistance R. This is the theorem for maximum power to be delivered across the load. Then this is the condition. Here, if you see that here you have to be very careful, very careful. The load is what? The resistor, the power generated in Y is maximum if Y is 8 ohm. That means this is the load. Then this load resistance should be equal to the internal resistance. So this 2 ohm and this R, you can consider it as a single resistor, isn't it? So because both are in series, what will be the equivalent resistance of this 2 and R? It is going to be 2 plus R. So you can have a condition now where the EMF of the cell is 10 volt and the resistance, excluding the load resistance, is nothing but 2 plus R. And this is the load resistance, which is Y ohm. And so for maximum power transfer, from the maximum power transfer theorem, this resistance and this resistance should be same, which is a load resistance is Y, and that should be equal to R, and that is 2 plus R. Y is given as 8 equal to 2 plus R, or R is going to be 8 minus 2, which is equal to 6 ohm. So it's a direct application of the maximum power transfer theorem. Next question. So we have here two cells of EMF 3 volt and 5 volt, and internal resistances R1 and R2 are in series. So the question states that there are two cells of EMF 3 volt whose internal resistance is R1. This is my first cell. And another cell is there whose EMF is 5 volt and the internal resistance is how much? R2. This is the another cell. They are connected in series across an external resistance R. The value of the external resistance is R. If the potential difference across the first cell is 0, then capital R is. Let us forget the question, what we can do from the circuit, you just think that. So whenever a circuit is given, we can calculate R equivalent, E equivalent, and we can calculate the net current supplied by the battery. So it's a one loop question. It is just one loop. It means that only one current can circulate. It means that all are in series. Only one current flowing means what? When can only one current flow? When all are in series, only one current can flow. And what kind of series? You have to be very careful now when cells are there. Now, what kind of series connection is this? It is series aiding. You know this point. If cells are connected in this fashion, then it is series aiding. And if the cells are connected in this fashion, then it is series opposition, isn't it? Series opposition. Opposite terminals connected, then it is series aiding. Like terminals connected, negative, negative, or you can have like this also. You can have like this also, positive, positive connected. Then it is series opposition. Series opposition. In case of series aiding, what is the equivalent EMF? It is going to be E1 plus E2. And in this case, E equivalent is going to be E1 minus E2. So finding out whether it is series aiding or opposition is a very, very important part. So here we can see that they are connected in series aiding. It's not mentioned. We can understand it is aiding, series aiding. So that what is the equivalent EMF? It will add up E1 plus E2, which is a 3 plus 5, and that is equal to 8. And since it is a series connection, what will be the final resistance? Final resistance will be R1 plus R2 plus capital R. After finding out the equivalent EMF and equivalent resistance, we can find the net current supplied with the battery. The current is how much? The current is the total EMF by the total resistance. Total EMF is how much? 8, and total resistance is R plus R1 plus R2. This is the current supplied by the cell. Fine. So after finding the current supplied by the cell, now what you can do, he's asking us the potential difference across the cell. Now you should be very careful with this word, potential difference. Potential difference. Most of the students find this part difficult. Potential difference means what? What is the meaning of potential difference? It is the terminal potential difference that he's speaking. That is, suppose for example, if the cell is of EMFE, internal resistance is R, this positive terminal will have some potential and this negative terminal will have some potential. If I take the difference in potential, positive terminal potential minus negative terminal potential, which is called the difference in the potential across the terminal, then it is going to be two cases are possible. If the cell is supplying current, that is current is flowing from the positive terminal of the battery, then the potential difference is E minus IR. We tell the cell is in discharging mode. The cell is in which mode, people? Discharging mode. And one more possibility is if the cell is charging. If the cell is what? If the cell is charging, that is the current is getting into the positive terminal. Usually current will flow from the positive terminal, but if you are connecting it into an external circuit such that the other cell is supplying current into the positive terminal of the other cell, then the cell is said to be in which mode? Charging mode. You just see if current is leaving the positive terminal, it is discharging. If current is getting into the positive terminal, then it is said to be in the charging mode. Then the positive terminal potential minus the negative terminal potential will be equal to E plus IR. And in this case, the cell is in which mode? It is in charging mode. It is in which mode? Charging mode. Now, where will the current flow from? The current will flow from the positive terminal of the larger cell. See, out of two cells, whenever you have to decide the direction of current, be very careful. You take the larger cell. Out of 3 volt and 5 volt, which cell will dominate? 5 volt. So current is going to flow from the positive terminal of the larger cell, because larger cell will dominate, isn't it? So we know current flows from positive terminal, but of which battery? From the positive terminal of the larger cell. So this, if I call it as cell 1, and this if I call it as cell 2, so current will leave the positive terminal, it will enter the negative terminal, and obviously it is going to leave the positive terminal of 3 volt also. So what is 3 volt? Because he's asking the potential difference across the first cell. What is cell 1 doing? Cell 1, we can see that it is discharging because current is leaving the positive terminal. So we can write, so positive terminal potential minus the negative terminal potential is equal to E minus IR, and this is specified that it is equal to 0. So 0 is equal to E. What is E for that cell? 3. What is the current that we got, people? 8 divided by R plus small r1 plus small r2 into small r. What is the internal resistance of that cell? Small r, small r1. Internal resistance of that cell, it is R1. So what will this become? So this will go this side. It will become 8R1 divided by R plus small r1 plus small r2 equal to 3. And then this will become 8R1 equal to 3R plus 3R1 plus 3R2. So 8R1 minus 3R1 is a 5R1. 5R1 minus 3R2 equal to 3R, or the value of R is going to be 5R1 minus 3R2 divided by 3. So that matches with option number 1, isn't it? That matches with option number 1. Is it clear, everyone? So let us go with the next question. 3 cells having EMFs and internal resistance are connected as shown. The reading of the ammeter. See, how are these cells connected? Cells are connected in parallel. See, whenever number of cells are connected, you should think whether it is a series combination or a parallel combination. Most of the time, if there are a number of cells given, it will either be cells in series or parallel. Otherwise, we can solve by Kirchhoff's laws. But before applying Kirchhoff's laws, you can easily solve the problem using series method or parallel method. Yes, we can see that these cells are in parallel. These cells are in parallel, but you can see that if you call this as EMF E1, internal resistance R1, this cell EMF E2, internal resistance R2, this cell is EMF E3, internal resistance is R3. You should be very careful that, see, the two cells are having this same polarity, but this third cell is connected with the reverse polarity, positive, negative, but you change the pattern, negative, positive you made. So therefore, in that case, you will take the EMF of the third cell to be negative. So when cells are connected in parallel, what is the equivalent resistance? I'm just finding for the cells. 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3, which is 1 by 2 plus 1 by 2 plus 1 by 1. Half plus half is 1. So 1 plus 1 is 2. You reciprocate. Therefore, R equivalent is going to be, this is 2 by 1. So R equivalent is 1 by 2 ohms. This is the equivalent resistance. What about the equivalent EMF? We have the result for the cells in parallel. E equivalent by R equivalent, the NCRT result, E1 by R1 plus E2 divided by R2. But because this cell polarity is reversed, we can use it as minus E3 by R3. So therefore, we can use this result to calculate the equivalent EMF. So equivalent EMF is going to be R equivalent will go this side, which is half into E1. How much is E1? 10 divided by R1, which is 2. E2 is 10. R2 is again 2. E3 is 5 divided by R3 is 1. 2 ones are 2 5s are plus 5 minus 5 will cancel. So 2 ones are 2 5s are 10. Therefore, E equivalent is how much? 5 by 2 volts, which is 2.5 volts. That means what? I can replace these three cells by a single cell, whose EMF is 5 by 2 volt. And what is the equivalent resistance of the cell or the resistance there? Half a ohms. And then an ammeter is there, and connect back your external resistor 2 ohms. I'll connect back the external resistor. Till now, I was solving only for the cells. So this is nothing but 2 ohms. And you can see that it's a one loop question. It's a one loop. That means only one current can circulate. That means all are in series. Therefore, you can, and there is just one cell. So you can find the current by using which formula? The total voltage by the total resistance using Ohm's law. What is the total voltage? 5 by 2. And total resistance is how much? Total resistance is these 2.5 are in series. So it is going to be 2 plus half. So this is going to be 5 by 2. 2 2s are 4. 4 plus 1, 5. Correct? 5 by 2, and that is equal to 1. So how much is the current flowing from the positive terminal of the battery, which is 1 ampere, and the same current will flow through 2, then it will flow through ammeter, then through half ohm, and then the same current will flow even through the voltage source, because all are in series. So 1 ampere, first option. Next question. So here the question tells 20 cells, each of EMF E and internal resistance R, are connected in series to form a loop. If the polarity of one of the cells is reversed, then the terminal potential difference, again he has used the word potential difference, terminal potential difference, potential across this cell. So you need to understand that he's speaking the positive terminal potential minus the negative terminal potential. First, you need to understand this point. Most of the students don't understand this. And there are two possibilities. Either it can be E plus IR or E minus IR, depending upon whether the cell is charging or if it is in discharging mode. Now, before doing this problem, I'll show you one more question. I'll do one more question so that you will get a better clarity of this. But here, what is the question is, here the question tells if the polarity of one of the cell is reversed. Let us not reverse any polarity, correct? Let us not reverse the polarity of any cell. Let us just connect. Let us say 20 cells are there. I'll mention here, this is type 1 question. How many cells? 20 cells. EMF is E and internal resistance is R. Are connected to form a loop. No reversing polarity. We'll just connect it like this. They are connected to form a loop. Now, what will be the terminal potential difference across any cell? The question will be here. Terminal potential difference across any cell. Any cell you need to find out. So how will we find? Again, it's a one loop question. One loop. One current will flow, means all are in series, isn't it? One loop, that means only one current can flow. It means all are in series and all are connected in series aiding. There is no reversing polarities. So what will be the equivalent EMF? E plus E plus E. If I have taken 20 cells, then it will be equal to how much? 20 into E. And what will be the equivalent resistance? 20 into R. Then you can easily find the net current supplied by the battery, which is the total voltage by the total resistance. And this is going to be E by R. This is the current. And where will current flow from? I told you, when there are number of cells connected in series, the current is going to flow from the positive terminal of the larger cell. All the cells have the same value, isn't it? All the cells have the same value, same internal resistance. So the current can flow from, you can decide the direction of flow of current from the positive terminal of any cell, because all are same EMFs, isn't it? So if I take the current flowing from the positive terminal of this cell, can you find the terminal potential difference across this cell now? Can you find the terminal potential difference across one cell? So I can write here terminal potential difference across any cell. Across any cell. If you see this cell, what is this cell doing? Current is leaving the positive terminal. So it is in the discharging mode. It is in which mode? Discharging mode. And in that case, the terminal potential difference is given by E minus IR. E is how much for that cell? E. Current is nothing but E by R. And what is the internal resistance of that cell? It is going to be R. RR will cancel and you will get this as how much? You will get this as equal to 0. So this is type 1 question. When you have cells connected in a cyclic loop format, and if all the cells are connected in the same pattern, positive, negative, positive, negative, positive, negative, without any reversing terminals, then the potential difference across any cell is going to be 0. Now the type 2 question is what is given here. Type 2 is what is specified here. 20 cells of EMF E and internal resistance R are connected in series to form a loop. If polarity of one of the cell is reversed, polarity of one of the cell, that means 19 cells were connected properly. 19 cells were connected properly. Only one cell was reversed. Only one cell terminal is reversed. Are you getting it? And what is the potential difference across this cell? That means across the cell to whom, correct, you have reversed the polarity, this cell. Terminal potential difference across this cell. So we need to find the terminal potential difference. Means we have to find V plus minus V minus. And this is one cell. So what you can do, all are connected in series aiding. First, you can solve this. This is going to be how much, people? 19E. 19E, because all are in series aiding. And what will be the equivalent resistance? Equivalent resistance has to anyway add up. Resistance cannot subtract. 19R. And then you have this cell. You have this cell whose EMF is E and internal resistance R. Now, again, it's a one loop question. So one current will flow, means all are in series. But here you should be very careful that it is series opposition. What series it is, people? It is series opposition, because here the like terminals are connected. Negative is connected to negative. When opposite terminals are connected, then it is aiding. And if like terminals are connected, then it is opposition. So in that case, what is the equivalent EMF going to be? It is going to be the subtraction of the two, 19E minus 1E, which is equal to 18E. Internal resistance will anyway add up, and 19R plus R, that will become 20R. And you can find the current, calculating EMF, resistance, and then the current. So that is total EMF, which is 18E by 20R. 18E by 20R. 2 9s are 18, 2 10s are 20. So this is going to be 9E by 10R. This is the current. This is the current flowing from the positive terminal. Now I told you, now comes the important part. Current will flow from where? Current is going to flow from the positive terminal of the larger cell. Which is the larger cell here? 19. So current will flow from the positive terminal of the larger cell. So the larger cell is discharging because current is leaving the positive terminal. This current will leave the positive terminal, it will flow, and it will enter the positive terminal of the other cell. It is going to enter the positive terminal of the other cell. That means what is this cell doing? Current is entering the positive terminal, therefore it is charging now. It is what? It is charging. When the cell is charging, what is the terminal potential difference? It is given by V plus minus V minus equal to E plus IR. Be very careful. In the previous case, all were discharging, but here this 19 cells are discharging, but the last cell which was connected with the reverse polarity is charging. And what is the EMF of that cell? E. Current is how much? You can see that current is 9E by 10R. And what is the internal resistance of that cell? It is same as R. So RR will cancel, and you can take the LCM. 10 plus 9, that is going to be 19E divided by 10. This is the potential difference. 19E divided by 10, that matches with option number 1. Fine. The next question here, it tells about cells. Before doing this question, let us understand a concept of this cells connected in parallel. Just see here. Let us say, suppose for example, let us say I have 2 cells or 3 cells. You can take n number of cells. Let us say this is a 3 volt and 1 ohm. And one more cell is there whose EMF is 3 volt and 1 ohm. 3 volt and then 1 ohm. What will be the equivalent EMF connected in parallel? Let us say one more cell, you can add up. How many ever cells you want, you can add up in parallel. But here the purpose to discuss this problem is, if you have same cells, that is same this EMF, same internal resistance connected in parallel, correct, in the same order, positive, negative, positive, negative, positive, negative, positive, negative. The question is, what will be the equivalent EMF and what will be the equivalent resistance? Since all are in parallel, equivalent resistance for n resistors connected in parallel, how much will it be? R by n. 1 by 1 plus 1 by 1 plus 1 by 1 plus 1 by 1. It will become 1 by 1, 1 plus 1 plus 1 plus 1 will become 4. Reciprocate that, you'll get 1 by 4. R by n. R and number of branches is 4. Or you can use 1 by R1 plus 1 by R2 plus 1 by R3 and 1 by R4. This is fine. What about E equivalent? Since cells are connected in parallel, you can use this relation. E equivalent by R equivalent is E1 by R1 plus E2 divided by R2 plus E3 by R3 plus E4 divided by R4. R equivalent will go this side. So this is going to be 1 by 4 into E1. What is E1? 3 by 1 plus 3 by 1 plus 3 by 1 plus 3 by 1, isn't it? So this is going to be how much? 3 plus 3 is 6. 6 plus 6 will become 12. So therefore it is going to be 1 by 4 into 12. 4 ones are 4 threes are. So 3 volt. I just took 4 cells. You could have taken just 2 cells, 3 cells also, no problem. 4 cells also you can take, 5 cells also you can take n cells also. The point is, if you're having cells of same value connected in parallel with the same polarities, isn't it? Positive, negative, the way of connection is the same, then equivalent is EMF is going to be 3 volt only. That is, it is independent of number of branches. If it is 3 volt, 2 cells, you check it out. It is going to be 3 only. You connect 3 cells, still 3. You connect 4 cells, still 3. You connect 10 cells, it is going to be 3. If you connect, let us say 100 cells also, it is going to be how much? It is going to be 3. Did you understand? So this is going to be independent of the number of branches. It is going to be same. Are you following something? So keeping this point in mind, let us solve a question. 24 cells, each of EMF 1.5 volt and internal resistance 0.5 ohm are to be connected. So there is each cell. What is the EMF of each cell, students? 1.5 volt. And what is the internal resistance? 0.5 ohm are to be connected to a 3 ohm resistor. So the external resistor is nothing but 3 ohm. 24 cells are there. How many cells are there? 24 cells. For maximum current through this resistance, for maximum current, if current is maximum, then what is the condition? Then power also will be maximum. Because what is the relation, people? Power is equal to, I'll just write it somewhere here. Power is equal to I square into R. If I is maximum, obviously power is also maximum. That means I have to use maximum power transfer theorem, which states that if you want to deliver maximum current or maximum power across the load, then that load resistance should be equal to the internal resistance of the cell, which we solved a few minutes before we solved the problem, isn't it? For maximum current through this resistance, the number of rows and number of columns that you can connect these cells is the number of rows and the number of columns that you can connect. So here what we can assume, let there be m cells in each row and let there be n columns, or let us say m cells in one row and let there be totally n rows. So I can assume what? Let m cells in each row, and let us say let n be the number of rows. You understood? N be the total number of rows. Are you following something? That is, let there be m cells in each row. M cells, cell 1, cell 2, cell 3, etc. up to m cell. In each row, let it be m cells be there. M cells, and like that, how many rows has to be there? N number of rows. N number of rows. N number of, we'll forget the external resistor for the time being. We'll leave it aside. So M cells in each row, like that, N rows are there, N rows. So what will be the equivalent EMF in each case? In the first case, E plus E plus E plus E. So it will become how much, people? It will be equal to ME. And what will be the resistance? Resistance is anyway going to add up. It becomes MR. In each branch, the equivalent EMF is ME. And what is the equivalent resistance? MR. Like that, how many rows are there? Like that, how many rows are there? Like that, n rows are there. Like that, how many rows are there, students? Like that, n rows are there. So if n rows are there, then what is going to happen? What will be the equivalent EMF? You tell me. Equivalent EMF, just now we learned that it doesn't depend upon the number of branches. If the EMF all are same, you can see ME, 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 ME. Even if you connect 100 cells in parallel, it is still going to be ME. But what about resistance? Internal resistance, what is the equivalent resistance? In one branch, it is MR, like that n rows are there. So it is going to be MR divided by N, R divided by N. R is the resistance in each branch. If there are N branches, you divide by N, isn't it? ME and then MR by N. Now you can replace this. What you can do, you can replace this now. So I'll replace it by one cell whose EMF is ME, and I'm replacing it by one resistance, equivalent resistance, which is MR by N. Now I'll connect back my load resistance. What is the load resistance value? The load resistance value is equal to 3 ohms. It is equal to how much? 3 ohm. And we can substitute. E is 1.5 and R is equal to 0.5 ohm. We will substitute that. And what is the condition? I told you, for maximum power transfer, for maximum power to be delivered across this load 3 ohm, that is maximum current will flow, then 3 ohm should be equal to the equivalent resistance, which is equal to M into R divided by N. What is R value, people? 0.5, which is nothing but half. So it is going to be M into half divided by N. So 2 will go that side. You will get M by N equal to 3 into 2, which is nothing but 6. You get one equation. M by N is equal to 6. M by N is equal to 6. You get one equation. And one more equation I want to, so that two equations we can find two unknowns. How many cells are there? 24 cells. In each row, there are M cells. Listen to this point carefully. In each row, there are M cells. Like that, how many rows are there? Like that, N rows are there. So what is the total number of cells? Total number of cells is equal to M cells in each row, and there are totally n rows, so it is going to be M into n, and that's given that there are 24 cells, totally 24 cells are there. So M into n is equal to 24. Call this as equation number 2. This is equation 1 and this is equation 2. Now, how do you solve them? You can just put M as equal to how much? M, you can put it as equal to 6n. Therefore, M into n is equal to 24. From 1, M we can write it as 6n. 6n into n is 6n square. So 6 ones are 6 fours are n square equal to 4. This implies n is equal to 2. Therefore, how many rows you should have? N was the number of rows, 2 rows. And therefore, what is M? Therefore, M is equal to 6n. That is 6 into 2, 12. So in each row, there should be 12 cells and there should be 2 rows like that. 12 plus 12 will become 24. So 12 cells in each row, correct? That is in series, and 2 rows in parallel. First option. Let us move to the next question. So here in the circuit shown in the figure, if the potential at A is taken to be how much? Is taken to be 0, then he's asking us what is the potential at B. So what we do, we use KVL. What technique we apply, people? We apply KVL. So how do we apply KVL? How do we apply KVL? You should just understand that in KVL, we write the voltages from positive to negative. If you move from here to here, positive to negative, there is a drop. So drop, we take the EMF to be negative. And if I move from here to here, negative to positive, the smaller one is negative terminal, the longer one is positive terminal. Negative to positive, what will happen? It is going to be rise. In that case, EMF, we can take it as what? EMF, we can take it as positive. This is for a cell. What about for a resistor? What about for a resistor? Resistor doesn't have any polarity, isn't it? For a cell, we can tell the longer one is positive, the shorter one is negative. But what for a resistor? So for a resistor, we can tell if current will flow in a particular direction, either from left to right or from right to left. You know, current is always going to flow from high potential to low potential. So wherever current starts, that is high potential positive. Wherever current enters, that is low potential negative. Did you all understand? So in this case, if I move from here to here, positive to negative, I'm moving. It's a drop. It's a drop. Drop should be taken. Drop means less. Rise means high. So drop should be taken negative. Rise should be taken positive. So what will you take? Negative, positive voltages. What is a voltage? IR. So IR will be taken as negative. If I move from here to here, I'm moving from negative to positive. That means it is a rise. So in that case, voltage will be taken as plus IR. Rise will be taken positive and drop will be taken as negative. So this point you need to remember. Now, so before applying KVL, you should know the polarities for the resistor also. You should know the current in each branch, correct? And you should find what? You should mark the polarities of the resistor and keep it ready. Cell, you need not have to mark. Cell already you know. You have to mark for the resistor. So how do you mark that? See here, 1 ampere of current is coming. 1 ampere is coming here. And here you can see that 2 ampere is there. That means in this branch, it is 2 ampere. So here, if it is 1 ampere and here it is 2 ampere, obviously then here it should be 1 ampere, isn't it? So that 1 ampere and this 1 ampere will combine and flow as how much here? 2 ampere. So this 1 ampere should flow from top to bottom. So this, wherever it starts, it is high potential. Wherever it enters, it is low potential. So now we have to start from A and move towards B. See, I can travel from A to B via number of paths. I can reach A to B via this path also. I can reach this path, but I cannot go through this path. The reason is I don't know the values of R2 and R3. Therefore, I cannot get to know the voltages. Similarly, I cannot travel from A to B via this path because I don't know the value of R1. Isn't it? R1 is unknown. Current I know, but I don't know resistance, so I cannot calculate the voltage. So the only way to reach from A to B is via this path. Battery is there, then this resistance and you knew the current, and this cell is also there. So I have to travel from A to B via which path? I have to move from here to here. then here, and then from here to here. So you start from A and then move towards B. So if you start from A and then move towards B, we are writing voltages. What is the potential at A? VA. First, I'll write VA. Starting from, VA. Then I'm moving from here to here. I'm moving from here to here. Go through this path. You can go in this manner or in this manner, anything. I'm going from A, I'm starting from A and reaching towards B. You can start from B and then reach towards A also. So if I start from A and then move towards B, so negative to positive, first VA, potential at A, negative to positive, rise, negative to positive, rise. So plus 1 volt. Then from here to here, negative to positive, again negative to positive, there is a rise, but here positive to negative, it will be a drop. So in that case, what is going to happen? In that case, negative to positive rise. What rise? Voltage. What is the voltage across the resistor? I into R. Current is 1, resistance is 4, and then positive to negative, a drop, -2. And then what I should write? Positive to negative drop. After reaching here, I reach the point B. I reach point B, positive to negative drop, and then I reach B. So this should be equal to the potential of B. I hope you have understood how I'm applying KVL. So I'm applying KVL to this path. Start from A and then move towards B. So wherever you're starting A, you take the potential as VA, and then negative to positive rise 1 plus 1, negative to positive again rise. So plus 4 into 1, and then positive to negative drop, and then I reach B. So this should be equal to potential of B. So VA 4 plus 1, 5, 5 minus 2 will be 3. So VA minus 5 plus 1, 4 plus 1, 5, 5 minus 2 will be 3, equal to VB. This is the equation. And the question tells that the potential is at A is taken as 0. So 0 minus 3 equal to VB, or VB is going to be how much? Minus 3 volt. This is the answer. Try to understand all the concepts so that you can solve further problems on your own. Next, similarly, we have a question here, the potential difference VA minus VB between the points A and B. So here what we can do is we have to again apply KVL, but before applying KVL, because all are in series, isn't it? It's just one branch, so only one current will flow, means all are in series. So you try to solve the resistance. 4 parallel 4, how much will it be? 4 parallel 4. R parallel, what about the resistance? It will be R by N. R by N. R is 4 and 2 branches are there. So 4 by 2 will be 2 ohms. Now that 2 ohms, this 4 ohm, this 4, this 1, this 2, and this 2 all are in series because it's just one path. So what will you do? You'll find the R equivalent. What is the total resistance? 4 plus 1 plus 2 plus 2. 2 plus 2, 4, 4 plus 4, 8, 8 plus 1 is going to be 9 ohms. Now I'll draw one cell that is 4 volt, and then I'll connect the resistor 9 ohm. See, it is immaterial whether both are in series, no, 4 volt and 9 ohm. You can place resistor first or the cell second, or cell first and resistor second. In series connection, it doesn't matter which you're placing first. I have just placed resistors to the right. If you want, you can place all the resistors to the left also. So in series, correct, you can place anyone first, either cell or resistor or a cell, doesn't matter. And then you can see the current is entering in this manner. So if you want to apply KVL, you should mark the polarities for the resistor. How do you mark the polarity for the resistor? Where does current start for 9 ohm? The current is starting, current will flow from left to right. Current starts from high potential and it enters towards the low potential, isn't it? So high potential to low potential. So what is the current here? Current is given as 1 ampere. So you mark the polarities for resistor and you move from A to B. If I move from A to B, what do I see? First, I'll see A. So potential at A is VA, then positive to negative drop, -4, then positive to negative again drop, minus what is the voltage? Current into resistance. And then after reaching this negative terminal, I reach point B. So this should be equal to the potential of B. Therefore, we get 9 minus 4, minus 9 minus 4 will be minus 13. So VA minus VB is going to be equal to 13 volt. This is the potential difference, isn't it? So option number 4. Is it clear? Fine. Just quickly make a note of this. Next question. So in the circuit shown in the figure, if a conducting wire is connected between the points A and B, then the current in the wire AB. So you're connecting the 2 points by a wire. Where will the current flow from? See, current is going to flow from high potential to low potential, isn't it? Current flows from which potential to which potential? Current flows from high potential to low potential. So what you can do first is, first find VA minus VB. Using KVL, you find out VA minus VB, so that we can get to know if VA minus VB is positive, then potential at A is more than potential at B. If VA minus VB is negative, that means B is higher than A. So we can get to know the direction of the current. So how do you find VA minus VB? First, you need to mark the polarities for the resistors. You should know current and everything. So how are these 1 and 2 connected? 1 and 2, actually they are connected in series. First, you try to solve. Before connecting the wire, these two are in series. So 2 plus 1 is going to be how much? 3 ohms. So this is going to be 3 ohms. And then 4 plus 2, that is going to be how much? 6 ohm. Battery voltage, let me take it as 1 volt for the simplicity's sake. 3 ohm, and then this resistance is how much? This resistance is 6 ohm, and both are in parallel. It is connected to a voltage source of how much? It is connected to a voltage source of 1 volt. So 1 volt means both are in parallel, so voltage is going to be same. You know the voltage and you know the resistance. You please find the current in that branch. The current is nothing but V by R. V is 1, resistance is 3. So 1 by 3 ampere in this branch. In this branch, what will be the current? V by R. V is how much? 1, correct, and resistance is 6, so 1 by 6 ampere. Did you understand? Okay, now therefore I got to know that in the top branch how much current is flowing, people? 1 by 3 ampere, and the current flows from high potential to low potential. So this is positive and this is negative. Here how much current is flowing? 1 by 6 ampere current is flowing. So current flows from high potential to low potential. So this should be positive and B should be negative. Is it clear? Now you find out VA minus VB. So after finding the current value, after marking the polarities for resistor, now you start from A and then move towards B. Now you start from A and then move towards where? B. I'll start from A and move towards B via this path. You can also move in this direction. Start from A and then move towards B. I'll just start from here and then move here. So I'm starting from A, correct? And then I'm moving towards where? Moving towards B. So therefore, what do I see? If I start from A, first I encounter the potential at A, which is VA. Then here, negative to positive, it's a rise. Plus, what is the voltage? Current, which is 1 by 3 into resistance is 1. And then here there is nothing. And then here, positive to negative, there is a drop. Drop, how much? 1 by 6. What is the voltage? Current into resistance, 1 by 6 into 4. And then immediately after traveling here, correct, I reach B. So that should be equal to what? That should be equal to the potential of node B. So 2 3s are 6, 2 2s are 4, 1 by 3 minus 2 by 3. How much is that? 1 minus 2 minus 1. Minus 1 by 3 equal to VB. Therefore, we get VA minus VB equal to 1 by 3. We get how much? We get it is equal to 1 by 3. 1 by 3. That means what do we get? VA minus VB, we got it as a positive value. Means what? Means, correct, A is at a high potential, correct, and B is at a low potential. B is at a low potential. We got a positive value, means A is higher than B. So we see that VA is greater than VB, and the current flows from high potential to low potential. This implies I flows from A to B. So if you immediately connect a conducting wire between A and B, the current is going to flow from A to B, that is from high potential to low potential, till the potential becomes what? Till the potential becomes same. So you can see the applications of KVL in different concepts, in different contexts we are applying. So KVL is very important tool to solve the numericals. Next question. The potential difference between the points P and Q. Again, he's asking us potential difference. So we can consider it as VP minus VQ or VQ minus VP, because he's not specified what we need to find. So we can find either of this. Now, you need to understand one important point. See, whatever current leaves the positive terminal, let us say I, the same current should enter the negative terminal back. You know this point. Yes or no? I'll start from P and then I'll move towards Q. I'll start from P here and then move like this and reach Q. So this part is not required for me, isn't it? I'll just start from P and then move towards Q. So if I move and before moving, first you need to find what? You need to find the current through the resistors, and you should mark the polarities for the resistors. To find the current, this is what I'm doing. So here what is happening, students? Here what is happening? The current is going to flow from high potential to low potential. That is from positive terminal of the battery. Whatever current leaves, we know that same current should enter back the negative terminal. So when is that possible? See, here if it is I, here also it will be I. I'll erase this back. First, you just understand this is I. This is I, isn't it? This is also I. And then you can see that here also, if it is I, the current entering the negative terminal, obviously this must be I. Now my question is, correct? My question is, so here there is a node, correct? There is a node here. So this I is coming here, but same I is entering. Why it has same I is entering? Because the same I has to enter the negative terminal back. So that means there is no division of the current that is happening, correct, at this node. You understood the point? I'll repeat once again. See, whatever current leaves the positive terminal, the same current should enter the negative terminal back. You understood this point. So here what I'm trying to tell you is, see, this is I, this is also I, this is also I. If this is I, you know that this also should be I. This also should be I. This also should be what I. That means whatever I is flowing here, the same I is moving here. That means there is no division of current that is happening at this node. No division of current takes place at this node, isn't it? So this cell doesn't supply any current through to this battery. Similarly, this cell also doesn't supply any current. I can just show it to you here. If this cell is current is leaving is I2, the same current should enter the negative terminal back I2. When is that possible? When this is I2. When is this possible? When this is I2. So same I2 is going to flow. Same I2 is going to flow here, 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 and only then it can enter the negative terminal back. That means there is no division of current I2 at this node. That means this cell also doesn't supply any current. So if I were to place a resistor here, correct, will there be any current flowing through this resistor? No, no, no. No current, and hence what will be the voltage? I into R. Current is 0, voltage is also 0. What is the power consumed? Power is equal to I square into R, correct? Current is 0, therefore resistance is also 0. Current is 0, resistance is also 0. You understood? Current is 0, therefore power consumed is 0. Are you following something? Is it clear? So what you do now, you try to move. You try to move. You try to move. From where to where you have to move? You move from P to Q. I'll erase this and I'll try to move from P to Q. So try to move from P to Q. Try to move from P to Q and check what you get. Try to move from P and then move towards Q. So just see here. Just see here. Just see here. Start from P and then move towards Q. So how much current will flow in this branch? I think you did this in this time. You might have paused for a second and you might have calculated the answer. The current in this branch is how much? Current is nothing but the total voltage by the total resistance. What is the total voltage? 4. What is the total resistance? 2 plus 2, 4. So how much is the current, students? 1 ampere. So 1 ampere of current will come, and that 1 ampere of current will flow here. I have to move from P to Q. So current will flow here, high potential to low potential. That's it, 1 ampere. Now you start from P and move towards Q. If you're starting from P and then if you're moving towards Q, so if you're moving towards Q, I'll start from P. Potential at P is Vp. Positive to negative drop minus what is the voltage? Current into resistance. And then from here to here, negative to positive rise plus 10. And then after this, I reach Q. So this should be equal to potential of Q. So 10 minus 2 is nothing but 8. 10 minus 2 is nothing but plus 8. So that is equal to VQ, or VP minus VQ is equal to minus 8 volt. Is it clear, everyone? This is the potential difference. This is the potential difference. Potential difference. Did you all understand? Potential difference. Potential difference. Minus 8 volt. 8 volt. Yeah, you're getting it. Fine. Just you have to calculate the magnitude. Are you all following something? Fine. We'll see the next question. Here, the next question states that in the network shown in the figure, each of the resistance is equal to 2 ohms, the resistance between A and B. So you just think, how many resistors are there? How many resistors are there? 1, 2, 3, 4, 5. 5 resistors are there. Whenever 5 to 6 resistors are there, I have told you, try to think of Wheatstone's bridge. Mostly all the circuits with 5 or 6 resistors land up to a Wheatstone's bridge. 5 resistors. So try to think of a Wheatstone's bridge. So first mark all the points. See, if this is A, This is also A because direct wire connection, isn't it? Points which are connected by direct wire will be at the same potential. This is A. If this is B, this is also B. And you can mark this point 1. First, you need to mark all the points. This is 1 and this is 2. You mark all the points. Now, thinking that it's a Wheatstone's bridge, try to connect the or try to draw the circuit in that format. So this is A and this is B. And 1 I'll place it here and 2 I'll place it over here. So how do you find the resistance now? Now you can start connecting the resistors. See, between this is A and this is 1, there is a 1 ohm between A and 1. So now you draw between A and 1, there is a 2 ohm resistor. This is done. Now next, you can take any resistors, whichever you want. Between 1 and B, you can see that there is a 2 ohm. Between 1 and B, there is a 2 ohm resistance. This is 1 and this is B, so this is 2 ohm. Next, between 2 and B, this is 2 and this is B, there's a 2 ohm resistor. So connect that. Between 2 and B, there is a 2 ohm resistor, right? Then next, between A and 2, there is another 2 ohm, and between 1 and 2 also, there is a 2 ohm resistor. So just connect the resistor, mark all the points and connect the resistors in that manner. So between A and 2 also 2 ohm resistance, and between 1 and 2. So I've connected all the resistances. And I have to find the resistance between A and B. We know that this is P, this is Q, this is R, and this is S. So what is the condition? We have to check P by Q equal to how much? 2 by 2, which is 1. R by S, I need to check. That is how much again? That is equal to 2 by 2, and that is also equal to 1. So therefore, we see that P by Q equal to R by S. Then we know that no current will flow in the middle branch where we used to have a galvanometer. So we can remove that branch. That branch will be redundant because no current is flowing there. And this 2 and 2 will be in series. So 2 plus 2 will be 4. And this 2 and 2 are also in series. So that is going to be 4. And this 4 and 4, how are they connected? Parallel. So 4 ohms. And then this 4 ohms, they are connected in parallel. So what will be the equivalent resistance? 4 into 4, R1, R2 by R1 plus R2. So it is going to be 16 by 8. That is nothing but 2 ohms. So 2 ohm is the answer for this question. 2 ohm is the answer. Next, equivalent resistance across A and B in the given circuit is. See, this circuit is symmetric circuit. What circuit is this, people? This is a symmetric circuit. There are many methods to calculate the equivalent resistance if it is a symmetric circuit. I will show you one simpler way. You can follow this. See, how do you understand that the circuit is symmetric? See, this is a line of symmetry, no? Don't you think this is a line of symmetry? Line of symmetry. It's like a mirror. And this and this, you can fold it, isn't it? This part, the one to the right of this line, isn't it? It's like the mirror image of the one which is to the left, or the one to the left is nothing but the mirror image of the right. So it's a symmetric circuit. It's a symmetric circuit. So in cases of symmetry questions, we can follow one method. So what is that method is, you just see here carefully how I do the problem. I'll take, for the simplicity's sake, I'll take all the resistance as 1 ohm. I'll take the resistance each as how much? 1 ohm, 1 ohm, 1 ohm, and then so on. And then finally, I'll multiply by small r. Each resistance is 1. So since you need to find the resistance across AB, what you do, you pass some current I. What you do, students? You pass some current I. So if you pass a current I here, due to symmetry, correct? See, the resistance are same. What is the resistance? Here also it is 1 and here also it is 1. So current IE is going to equally divide in these two branches because the resistance are same. It is equally going to divide. So therefore, how much is this resistance? 1 and 1. So current will equally divide as I by 2 here. Out of I, same I by 2 will flow, isn't it? I by 2, same current. I will equally divide because the resistance are same. Then after this, you come to this part. So whatever current enters the circuit, correct, the same current should leave. So here, if it is entering is I at this node, the same current should leave the node I. This is I. So if the current leaving is I, and since the resistance are same 1 and 1, so that means this should be I by 2 and this should be I by 2, so that both I by 2 will combine and flow as what? It will flow back as I. And why it should be I by 2? Because the resistance are same and it's a symmetric circuit. Now you just see here, see the bottom branch. That bottom branch is very important. So how are the, what is the current flowing in these two branches? Don't you think it is same? Yes, it is same. I by 2 here, I by 2. Means how are they connected? Means they are connected in series. They are connected in series. That means actually if you see this node, so there is no use of that node actually. If you see this node, there is no use of this node. If that node, correct, if that node actually had some effect, then what should have happened? What should have happened? This I by 2 which was flowing here should have got divided. Should have got, this I by 2 should have got divided here, here, and then here. That means if here if it was I by 2, then some current should have flown here, some current should have flown here, some current should have flown here. But you can see that whatever I by 2 is entering, the same I by 2 is leaving. That means there is no division of current that is happening at this node. There is no division of current that is happening at this node. No division at all. No division of current is happening at that node. Entire I by 2, whatever is entering, the same I by 2 is leaving. That means I can consider that node as an independent node. What I can consider, people? I can consider that node as an independent node. I'll just redraw the diagram. You can understand like this. That node can be considered as an independent node. What is the reason? Because here also I by 2, here also I by 2. If that node actually had some effect, it should have divided the current, but there is no division of current. That means, therefore, that node can be considered as what? An independent node. What node, students? Independent node. Now you can easily solve the network. Only this point, if you understand, you can easily solve. So how are this resistance and this resistance connected? In series, isn't it? In series. So it will be how much? 1 plus 1, that is nothing but 2. Now that 2 and this 1, how are they connected? This is that 2. Isn't it? And this is that 1, which at the top. This 2 and this 1 are connected in parallel. And this 1 here, correct? And this 1 are there here. So 1 here and then 1 over here, isn't it? And then this 1 and 1 are connected in series. So that is going to be 2. That is going to be 2 ohms. This is my B and this is my A. So you can see that this 2 and 1 are connected in parallel. So how much will that be? 2 parallel 1. That is nothing but 2 into 1 divided by 2 plus 1, which is nothing but 2 by 3. 2 by 3 ohms. Now you can see that 1 ohm is there. And then this is 2 by 3 ohm. And this is nothing but 1 ohm. All are connected in series. And that is in parallel with the 2 ohms because these are the 2 points, B and then A here. So these 3 are now in series, isn't it? So this will be how much? 2 by 3 plus 1, which is 2. So this is 3 2s are 6 plus 2, 8 by 3, and this is 2. So 8 by 3 is in parallel with the 2. So that is going to be R1 into R2 divided by R1 plus R2. So 8 2s are 16 by 3, the whole divided by 3 2s are 6, 6 plus 8, 14, 14 by 3. And this will become 3 3 will cancel, 2 8s are 16, and 2 7s are 14. So this is going to be 8 by 7. Finally, I'll multiply by R. I took it as 1. You be on the safer side, take all the resistance as 1 if there are a number of R's. And then finally, what you do, you multiply by R. So 8R by 7 is the answer. So second option. Next question. The equivalent resistance between the points E and B of an infinite network. So it's an infinite ladder. These are the NCERT questions which have been asked in the competitive exam. NCERT exercise questions, these are. 2 questions are there. Here I'm just doing 1 question. So now what you have to do is in infinite ladder network questions, it is purely a mathematics based question. This is 1 ohm, this is 1 ohm. This is also 1 ohm, 1 ohm, 1 ohm. This is also 1 ohm, and so on. He is asking us the resistance between A and B. So what we do in this kind of problems is you assume let the resistance between A and B be X. Let the resistance between A and B be equal to X. So now infinite patterns are there. What you do, you try to find out a pattern which is repeating again and again. See here, this is 1 and 1, 1, 1, 1, 1, 1, 1, and then so on. You find the basic pattern that is repeating again and again. Which is a basic pattern that gets repeated again and again? This is that basic pattern. 1, 1, 1, 1, 1, 1, 1, 1, like that. Basic pattern. You keep that pattern as it is. You call this points as C and D. You call this points as what? C and D. Leave that basic pattern. What is the resistance from between A to B? From A to B, if I see, if you keep a meter, how much is the resistance? X, isn't it? Resistance is X. From C to D, if I measure, what will be the resistance? It will still going to be X only. You understood? You keep one basic pattern as it is, isn't it? From A to B, if the resistance is X for the whole network, you just remove one basic pattern. And if you take 2 points C and D, and from there, what will be the resistance? It will still be X because it is an infinite pattern. In the infinite pattern, one pattern, if you just remove, if the whole resistance is X, then out of the infinite patterns, if you remove one, still it is going to be X only. It is not going to change because it is going up till infinity, isn't it? I have just removed one pattern. I have just removed one pattern. If I remove one pattern, and still I can call the resistance between these 2 points as what? X. Did you understand something? I'll repeat once again. I have called the resistance between A and B as X. Now what you do, you find the pattern that is keep on repeating. So this is 1 ohm and 1 ohm. You separate that out, isn't it? Now, if after separating, now 2 points are left out. What is the resistance between the 2 points? Call them as C and D. It is still going to be X only, because out of infinite patterns, one pattern if you remove, nothing is going to happen. So therefore you replace now. Now from here it is completely mathematical question 1. And from C to D, what is the resistance? It is nothing but X. So I'll put a resistance, resistor of resistance X, and this is AB. Now you find out by your method what is the resistance between A and B. So how are these two connected? Parallel. In parallel, what is the resistance? R1 into R2, 1 into X divided by 1 plus X. So this is going to be X divided by 1 plus X. Now this and this, X by 1 plus X and 1 are in series. Therefore, what will be the resistance between A and B finally? The resistance between A and B finally is going to be a 1 plus X divided by 1 plus X. Now you try to solve this. So 1 plus X plus X, 1 plus X plus X divided by 1 plus X. And what is the resistance between A, B? I have already assumed that let the resistance between A and B be equal to X. Therefore, this will be X equal to 1 plus X divided by 1 plus X. You cross multiply, you will get X plus X square equal to 1 plus X plus X. You can see that 1X and 1X is going to cancel. You get a quadratic equation X squared minus X minus 1 equal to 0. This is a quadratic equation in X. Quadratic equation in X, and it is not factorizable. You have to solve by the formula method. This matches with what? AX square plus BX plus C equal to 0. And we see that A is equal to 1, B is equal to minus 1, C is equal to minus 1, isn't it? So what is the value of X? It is a minus B plus or minus root of B square minus 4AC by 2. If it is factorizable, you do. If it's not factorizable, you can go with the formula method. Minus B. Minus B is minus 1. So minus of minus will be plus root of B square 1. 4 into A is 1. C is minus 1 by 2 into A. 2 into 1. Minus of minus will be plus. 4 plus 1 is going to be 5. So this is going to be 1 plus or minus 5 under a root divided by 2. So root 5 is more than 2 because root 4 is 2. So this value, if you take minus 1 plus root 5 by 2, isn't it? And then you have 1 minus root 5 by 2. This value will be discarded because X you will get negative. 1 minus root 5 will be negative value, and resistance cannot be negative. It cannot be negative. So we will discard this. So what is the resistance? Therefore, the resistance is equal to 1 plus root 5 divided by 2 ohms. This is the value. So infinite ladder network should be solved in this manner only. Next question. It's a very good question. A metal wire of resistance 3 ohm is elongated to make a uniform wire of double its previous length. This new wire is now bent and ends are joined to make a circle. If the 2 points on the circle make an angle 60 degree at the center, the equivalent resistance between the 2 points will be. So here, these are like 2 questions asked in one problem. So a metal wire of resistance 3 ohm is elongated. It is stretched to make a wire of double its previous length. So we know the formula. We know that formula. If you stretch the wire, isn't it? If you're stretching the wire, so length is going to increase, but area is going to decrease, but volume will remain constant. And for stretching problems, we know that R is proportional to L square, isn't it? So first we will find out what is the new resistance, isn't it? R proportional to L square. So we can use R2 by R1 equal to L2 by L1 the whole square. This is for stretching cases. For stretching case. So R2 is unknown. R1, what is the initial resistance, people? 3 ohm. L2, it is stretched to make a wire of double its previous length. So L1, if you take in the initial case L, what will be the length in the final case? 2L the whole square, because whole square is there. L and L will cancel. 2 square 4. This implies R2 is equal to 3 into 4, which is nothing but 12 ohms. This is the resistance now. This is the resistance. Now what you do? Now see the question. It is stretched to double its previous length. This new wire is now bent. is now bent and the ends are joined to make a circle. Now this wire was there. No, what is the resistance of that wire? 12 ohm. It is now bent in the form of a circle. It is now bent in which shape, people? It is bent in the form of a circle. Let me draw it over here. It is bent in the form of a circle, that wire whose resistance is how much actually? The resistance of this wire is 12 ohm. It's not 3 ohm. 3 ohm is elongated and then it is made in the circle. So after elongating, you need to find the resistance of that new wire, no, which is R proportional to L square. Now this new wire is bent in the form of a circle. If the 2 points on the circle make an angle 60 degree at the center, there are 2 points, it seems, let us say E and B, which are making or subtending an angle 60 degree at the center. So you need to find the equivalent resistance between E and B. Are you following something? So now how does this diagram look? How does this diagram look? Here also little math will come. See, I'll keep this as E and this as B. Yes or no? This part of the wire will have some resistance. Let me call that as, say, R1. Let me call that as R1. And R1 is connected between A and B. R1 is connected between A and B. And then another part, correct? This part will have some resistance that will, let us say, that is R2. And that is also connected between what points? A and B. A and B. This is also R2 connected between A and B. And how are the two connected? They are connected in parallel. So first you need to find R1 and R2 values. So how do we find R1 and R2 values? How do we find R1 and R2 values? R, we know resistance of the wire. Lengths are different for the two wires. R is rho L by A, isn't it? For the two wires, correct? This one wire and this wire, what is same? The cross-sectional area is same. The cross-sectional area is same, only the length is changing, correct? For the first resistance, length is more, and for the second wire, correct, the resistance is less. So R is equal to rho L, and arc length, L is nothing but the length of the wire. We know arc length. We know arc length. I'll just mention it here. So if this is the arc length L, correct, and this is the radius, so we know the relation between L, R, and theta. L is equal to R into theta. This kind of analysis will come even in moving charge and magnetism. So please pay attention and listen. Try to remember this. Try to grasp this result or the method as much as possible. So we can tell R is proportional to length. Okay. Or even if you don't want to use this relation, you can simply tell resistance is proportional to length, and that length is proportional to theta, isn't it? More is this length, correct? More is this length, obviously more will be the value of theta, isn't it? So R proportional to L, and that is proportional to theta. Therefore, R1 by R2 will be equal to how much? Since it is proportional to theta, I'll get theta 1 by theta 2. This R1 subtends how much angle at the center? Total angle is 300, and R1 is subtending 3. This is already 60. So this will be 360 minus 60, which is nothing but 300. And then second part. How much second part? Second part of the wire will subtend how much angle at the center? 60, isn't it? So 6 ones are 6 5s are 30. R1 is subtending 300 and R2 is subtending 60. So R1, you will get it as equal to R1 by R2 is 5, or R1 is equal to 5R2, isn't it? Now, the next part is, but what is the total resistance of the whole wire? 12 ohm, isn't it? We calculated from here. So, but R1 plus R2 should be equal to how much? Should be equal to 12 ohms. R1, you can put it as 5R2. So 5R2 plus R2 will be 6. R2 equal to 12. So 6 ones are 6 twos are. R2 is going to be equal to 2 ohms. And we got R2. This implies R1 is 5 times of R2. 5 into 2, that is nothing but 10 ohms. Now we got to know R1 and R2 values. Now, therefore, these two are in parallel. So the resistance in parallel combination is given by R1, R2 divided by R1 plus R2. R1 is 10, R2 is 2. 10 plus 2, that is nothing but 12. So 2 6 are 12. 2 6 are 12, 2 3s are 6, and then 2 5s are 10. So R equivalent between A and B will get it as 5 by 3 ohms. Option number C.